So I'm Matt Thompson. I'm a chartered engineer with 20 years experience in renewable energy. I'm co-founder and CEO of PowerMy Hub, who trade as PowerMy EV. So everything in this presentation refers to PowerMy EV. So I'm here to give the show and tell about Project FET. Project FET is a project that brought together a number of different project partners, including Everose, Delta E, University of Bristol, many others. We had lots of other collaborators, experts in the field, and then also many consumers, users of the service. So Project FET is all about helping consumers go electric. We see the electric car as the tangible starting point to the net zero challenge, and we're there to help them get engaged and start that journey. As things get more and more complicated, as they inevitably will with heat pumps, smart tariffs, our aim is to make it simpler, but yet keep it meaningful. In a decentralized energy network, it's important that we optimize locally, and that's part of our objective. So PowerMy EV is an electric car and home energy matching website. We help consumers explore electric cars or the latest on the market, see their attributes. We then bring in the element of home charging and how they can connect their car and power it with clean green energy. So that's both solar generated on the roof, but also a smart EV tariff. And then we connect them to suitable suppliers. We offer a quick, free and impartial service. So why Project FET? Well, today we're helping people like Richard who get it, they're convinced by EVs and they want to power their car with clean green energy. We currently offer the only time of use and smart meter comparison tool, free to use, that incorporates user patterns, so both their car use and their home energy use, which is great, but it's not mass market ready. We need to make it easy to use, yet meaningful for people like Simon to get involved. As I said, as things get more complicated, people like Simon are more likely to be to sit on the fence. When there's more and more decisions to be made, it's much easier just to not make a decision. And we want to help Simon make that right decision. People like Simon in the mass market, the early adopters, are comfortable with using familiar digital journeys around comparison sites to find the right deal. And that's what we're aiming to do. We're looking to create a simple, quick, efficient comparison tool that looks at particularly EV home energy bundles. So within Project FET, we have three main areas of focus. We looked at consumer research, we focused on the user, understanding them, and we did that through a user survey and choice experiment. We asked lots of psychographic questioning to understand behavior and attitudes, undertook cluster analysis to evaluate segments and come up with architects and specific use cases. We also, we currently hook up many different data sources and have our own databases, external databases, very comfortable pulling in data from lots of different areas. And we wanted to extend that to make it more tangible to the consumer and also more relevant. And one way we did that within this project is look at the current car and show its relevance to going electric, so the CO2 impact of changing and the total cost of ownership. We also incorporated the longer route checker. So one of the concerns that consumers have is around that longer journey, can they do it? And we incorporated that. And then finally, modeling to ensure that our total cost of ownership modeling methodology and carbon capture methodology were suitable. We had two third parties, Everose and Delta EE, review our methods models to make sure they were appropriate. So I'm going to give you an example of our website, and I'm just going to make sure that you can see my screen. So this is a live site, so given the sort of constraints of a fairly short time frame, and wanting to look at both consumer research and also test our user interface, we decided to embed a lot of the psychographic questioning and survey questions into a web tool. And we then went out to consumers and asked them to engage with that. Now that was great because it really gave us insight into how they behave. And this is a live site. So if you go to survey.powermyev.co.uk, you can see this site in action. And I'm going to talk you through it now. So we start with, like I mentioned earlier, the current car. Now this enables the consumer to get engaged. I'm actually going to put in a real car. And as you can see, it pulls up. So we're connecting to the DVLA database here, and also the MOT database to look up the make, model, and also a prediction of the annual mileage based on their MOT records. Now, the last sort of couple of years have been slightly odd, so I'm just going to sort of change those mileage there. But what we then do is do a calculation to estimate the fueling cost for the consumer, and then make a prediction of total cost of ownership. So that includes potentially finance cost, depreciation costs, and running costs, so maintenance costs. And that's a factor of the age of the car, the CO2 emissions, the mileage. So this is just to give some context to get the consumer to sort of buy in that we understand them. Now, obviously, that's a double-edged sword because consumers can say, well, you know, that's not me. So we do have information labels here to just help them understand how we've come up with those figures, so that they've got some understanding. We then move on to saying, well, you know, what kind of car are you looking for? What car would suit you? Electric cars do currently look different, and there's an opportunity for a break-in in brand loyalty. So we ask a sort of fairly generic set of questions, or saying, well, you know, what key features, what type of car are you looking for, and then come up with a match. Towing is an interesting one. I'll come back to that in a bit. And then we come up with from our database of cars, we come up with and calculating our sort of a match. We come up with a number of different cars that the user can then sort of explore and filter on with different attributes. So we then allow the user to select up to 3 to compare, and I'll come back to the reason why in due course. But we're showing them attributes in terms of the real range, the MPG. So most people might be familiar with MPG, but the electric MPG is much higher. So I think that is a good way of sort of interesting consumers. I think that the higher costs are obviously something that we had a lot of feedback saying, well, you know, that's a concern, and I'll come on to that in a bit. So then what's really important in the context of understanding journeys is when the cars are at home. And so we ask a number of questions around how the user uses their car. So I'm just going to put in some numbers. Can you charge at work? Is this a company car? So it's fairly standard questions you want. I think the one which is a bit more interesting in terms of, you know, how many longer journeys do you drive a year? And we had quite a large variation. I'll come on to the survey responses in a bit, and then we come on to a longer journey checkout. One interesting thing is that we did see that consumers felt that we initially had this question as required, and that was a real blocker. People didn't like putting in specific journeys that they thought other people might use. So we had to make it optional. But what you can see is that I've chosen Western Supermare here. And that's the classic circle of doom. Oh dear, but it does normally come up with the longer journeys for this particular journey, and the charging time that that car would take. Okay, oh, there we are. So, well, that's not a, there we are. So it's picked up Bromley, 141 miles travel time. In this particular car that has been selected, there's no charging en route. So I think it provides some reassurance to the consumer that you know, for a longer particular journey, that they wouldn't be left waiting, or if they have to charge, then what that timing is. And then sort of central to our mission is about bringing the car and the home together. So we ask questions around the home. We ask around off-street parking. We ask whether someone has a smart meter or not, and then why they potentially got one, because that can impact on in terms of the potential EV tariffs they can access. We then ask them around how they use electricity in the home. And I'll come on to the results that we saw. We asked them how much do they use. One area of the development that we've made on the back end but haven't quite implemented it in the user interface is that we can now look up annual energy yield, or annual energy use, electricity use consumption, using the Electrolinks API. Ask them how much they pay, what their region is. Now that's important in terms of carbon intensity and cost. Then we ask them about solar PV. I'm not going to go through, if they click they're interested, we can take them through a journey that helps sort of map solar onto their house. But in this case, I'm just gonna speed on. So then we undertake quite a detailed calculation. It's a time domain analysis for each car. We make predictions around the journey profile use, the home energy use, and then we create some algorithm. We use a forecasting algorithm around when would be best to charge based on different types of electricity tariff, and if they've considered solar, that's also incorporated. And then we come up with a charging report looking at their different the cars that they've selected. Now, at the moment, we're due to that calculation, we limit it to about 3 cars, because that's much easier. We then offer the user some further information on how that match has come up, how we've calculated the cost per mile, and also one of the sort of a bit more detail around what that actually means. So we say, you've put in your annual mileage, you've said you commute 4 days a week at this many miles, so that's typically 200, and then the number of longer journeys, that's typically 200 miles. So what does that mean in terms of charging? Well, in this case, 9 hours using a 7 kilowatt home charger. Now, we then make a statement saying, well, looking at your use patterns, your car is typically at home for 102 hours a week. So we hope that this type of information helps inform the consumer around electric cars. So as part of the choice experiment, we asked them to choose one and progress. And then we offered 3 different types of bundles. So a standard car only lease proposition, a car and home energy bundle, and then a full subscription model. So this is part of the choice experiment, and we wanted to see how they interacted. In each case, we presented the cost to them, but also included a cost of ownership price, which you can see doesn't really vary too much across the different offers, but will change and be different due to different overheads and the services that operators are providing. In each case, we make a prediction around the saved CO2, and also we compare it to equivalent petrol car, which we feel is important to be able to sort of get some sort of context. So that's looking at an equivalent petrol car and then the total cost of ownership over a 4-year period. So then we provide some summary back to the consumer. So hopefully that's given you an overview of what we've done within this project. And as I said, that was really embedded. That whole process was a survey and a choice experiment. So I just want to touch on some of the results. The first thing to say is the demographics that we targeted to get the users through this, this journey were based on Norway. Our focus is on the next 30% of EV drivers, the early adopters, and it just so happens that Norway's at that point currently. So we targeted the demographics both in terms of age profile, gender. You can't target people using digital marketing on income in the UK, but you can use proxies for that. And we just monitored how the demographics that we were coming through the site and adjusted accordingly. We saw that our distribution of car reg were very similar to the national scale, although they were higher in our target audience. So this plot in the middle shows that the plates 19 and 18 were higher participants, which is great because they're in market for buying cars, so they've got a lot of interest. And then the plot below just shows that generally the car colours of the current cars of the consumers going through the site match the national average. Overall, we had great engagement. We had lots of people come through the site. So we got a lot of qualitative data or quantitative data, but we also got some really good insights via the qualitative data and the feedback and the Facebook comments, particularly around towing. I just want to touch on some of the results because I think that would be insightful for some. Journeys are really important because there is very little published data on what consumer profiles look like for different segments. And so we built on some work here undertaken by Gillian Annabelle at Leeds University and asked questions around what type of car what type of journeys do you most commonly make? What are your longer plots? And we've got some interesting results that we're going to feed back into our modelling. Also, we're looking at the home energy. 82% have off-street parking. That matches with the demographics that we were targeting. Encouragingly, 50% they would be interested in home solar. 14% already have some. And also encouragingly, 50% said they would potentially shift their energy use overnight if it was cheaper. The other 20% of peak, 30% in the day use represented the demographics that we were targeting, the retired subsector and the families as well. The smart meter again, 52% have a smart meter. That's a gauge reflects the demographics. So we ran the numbers through the cluster analysis and discovered 3 main EV buyer segments and 3 main energy segments. So one of the main hypotheses that we were looking to explore was whether the engaged EV drivers and the engaged energy consumers, whether there was an overlap there, because we see those as being the sort of target, sort of low-hanging fruit for EV, for managed home charging. And we were very encouraged by the results and the correlation between those 2 segments. I think generally both the segments that we identified match prior research around EVs and around energy. So we were encouraged by those also. So just to summarize, our mission is to simplify and enhance the consumer experience of going electric. MedApps has enabled research into identifying new user features, accessing new data sources, and doing some much needed consumer research, understanding archetypes. We've now got definitions of what those archetypes look like and some use cases around that. So some of the outcomes, much greater insight from, had stakeholder engagement. We spoke to lots of experts, but most importantly, we got feedback from consumers and spoke to them about their experiences. We have enhanced the website that, like I said, was focused on the early adopter, and we feel that we've made lots of key features that are really good, and we can embed them back into a smoother customer journey. And it's been tested again by lots of consumers. And we've also come up with some novel segmentation around those car and home energy bundles, which at the end of the day is a real reason for moving electric, is to enable more renewables onto the grid and achieve our net zero target. So I think that's me.
Brilliant. Thanks very much, Mark. That was really interesting. So in terms of your engagement with the Open Energy project, were you able to integrate with any of the initial outputs from that, the architecture, any of the data sets?
So we looked at the architect, and it's all very doable. We already operate. We have a front end and a back end which talk via API. We're very comfortable with the whole proposition of the open energy. I think at the moment they don't have the data sets, but we would be very well in the future. We would be very good customers. We'd be keen to access some of the process smart meter data, for example. We're there, we're ready. In terms of providing up some of the data, I mean, I think we're keen to do more research, and we can help provide insights back to the industry. And again, we have the ability to host that data and serve it up via shared APIs. That's not a problem. So yeah, we see the potential, but we haven't accessed any of the sort of the dummy data because it wasn't quite right. Or, trial data, I should say.
Brilliant, thanks. In terms of where you have integrated with your website with live APIs, you said you mentioned the DVLA and the MOT database. Was there any kind of authentication or access challenges there that you think maybe having more of an open data architecture like Open Energy would have helped with?
So those two APIs are available to parties who make an application. So getting the DVL data is fairly straightforward. The MOT data was more of a challenge, but thankfully, due to sort of Innovate UK, they were seen as that we were a credible outfit. We weren't just there we had a genuine cause rather than trying to use it for illicit purposes.
Brilliant. Okay, great.
We've also accessed the Electrolink data as well. So that's sort of annual electricity consumption for the user. Unfortunately, didn't have quite time to embed it into the survey, but have made that. We've got that sort of working back end and it on staging servers.
Okay, brilliant. Okay, fantastic. So we've had a question. So data accuracy is a challenge in all applications. For this one, in light of the Dieselgate, how do you communicate uncertainty in range, battery performance, emissions, etc., to the consumer? Or do you simply use the manufacturer's numbers?
So two things there. The first thing is we don't use the manufacturer's stated or the certified stated range. We use roughly 80% of that. So to provide a real range, we feel that's really important. One thing that we would really like to do, and this is sort of where we'd like to sort of have some resources to do in the future, is to look at, so we're currently doing a time domain analysis. We take a typical week, but we haven't quite done the sensitivities around that. And it's quite easy to do that with seasonality. And we'd like to run, lots of simulations and then use the machine learning tools to come up with parametric models. So then we're using a science-based approach to come up with simplified models. And that's, to me, is the sort of win-win. That's where we'd like to take it. So at the moment, we're being conservative, whereas what would be nice to show is maybe a bit of uncertainty to the consumer in terms of plus and minuses.
Okay, brilliant. And in terms of how do you in terms of kind of the cost figures that you're presenting to the consumers, so the cost of ownership a month, have you been able to validate those estimates anyhow?
So we've got insights into the finance of the cost of the car. That's the sort of main thing. But then we use market rates for evaluating cost of electricity, other charging costs. So we had Delta EE and Everose go through our methodology and look at the assumptions we were making. So we feel that we've got, the best industry sort of standard that is possible. Validating it, I think, would be quite an interesting one. Getting sort of consumer feedback on how much they actually do pay, and how that depreciates with time as well. So we incorporate depreciation. There's still, that's an uncertainty in its own right for electric vehicles, although looking much more encouraging than petrol cars. And again, we make assumptions around servicing costs. So all of those sort of factors are well, one of our next sort of plans is to publish and show our methodology. We feel that leading the pack here is important, set a high bar, because otherwise there will be it's very easy just to come up with numbers, isn't it? So our approach is to present our methodology and let the consumer, if they're interested, have a look and ask questions.
Okay, brilliant. So your cost of ownership is currently based on kind of time of use tariffs, but have you had any thoughts about possible integration of more dynamic DSR and also vehicle to grid?
Yeah, so we incorporate agile as the only sort of tariff on the market. So that's already in there, and we look at what the optimum is. So it's really interesting. So if you've got solar already and you're using energy during the day and you're not using a car during the day, it's sitting there, then we incorporate own generation, and agile often works better in that situation than an overnight EV tariff. So that's already baked into the calculations. And then vehicle to grid, well, I guess what we're doing is we're having to make assumptions around how you forecast, well, how you've got to have a charging algorithm in your calculations, otherwise it's so we make assumptions around when it's best to charge. So at the moment it's just about charging when it's cheapest or free energy if you're generating it yourself. But we've also got in the calculations vehicle to grid at that point, as and when it arrives. Okay,
great, thank you. And in terms of taking this into the next beta phase, what's kind of in scope for your project?
Yeah, so I think what we've there's three sort of main areas. We've scratched the surface with the consumer research. We feel that there's there's some greater insights that we can get in terms of those consumers. So for me, managed home charging is really important because it enables much more renewables onto the grid. There's no point getting electric car. Electric cars are great, they drive better, they don't have tailpipe emissions, but they what they're really good at is potentially sucking up spare renewables. And so the best way for the mass market to engage with that is to get comfortable with managed home charging. And so we would like to explore that more. And we've had a lot of input from utilities saying that's of real interest. So that's sort of one area. We'd like to then take the features that we've developed and put them into a beta tool and just explore. We had quite a few blockers with data entry, so providing the consumer with a simpler way of engaging. So generic data, just to give insights. And also I showed one example of the report. Many people didn't click on that, and so we need to look at how we can enhance that with visuals, animations to help sort of get that sort of better messaging across. And then finally, we need more data. There's just not enough understanding of both consumer use profiles per subsegment. We're using the same off-gen profile that we've been using for years, so that's one thing. And then also on the journeys, there's very little information in the public domain around what sort of typical user journey. So those are the two key things that we would like to explore further with further research. And then also on the modeling side, like I mentioned, we want to move away from the time domain modeling into more parametric models, but we need to run the simulations and do the machine learning for that. So that's sort of a third part of the work.
Okay, brilliant. And as with the other two presentations we've had today, the final question being, what are your top 3 additional data needs?
Yeah,
were you able to get hold of them? Do you know where they are?
I guess I've already answered some of it. Journey data, well, process journey data served up on a plate per segment type. That'd be brilliant. Similarly, smart meter data per segment type. We've already got the bespoke annual energy, so that's covered. And then the third is actually probably whether a consumer can get smart meter data, a smart meter, sorry. Interestingly, anecdotally, we had a lot of people saying we can't get a smart meter, and we thought that was quite interesting. And I think it would be nice to be able to tell a user during the journey, oh yeah, you're going to have to think about this now, because by the time you get, if you're waiting for your car, you might as well start the process. So that, yeah, that would be the third one.
That's an interesting point on the smart meter availability or compatibility. Might be worth talking to someone like Smart Energy GB about.
Yeah, we have.
What.
They're planning to come up with a list. But it's kind of, there's two different systems, and people talk about the network. So in the north of England, it's very different to the south of England, and then you're reliant on a 2G network. So you could just use that, but they're also saying that the networked system will come very soon, and so there doesn't seem to be a coherent message on when that will be. So it's a wish. I don't expect it to happen too soon.
Okay,
but if
brilliant.
anyone's on the call and knows, please get in touch and put me right.